Cold mud, frozen steel, an army paralyzed. In 1943, the Eastern Front was not won by the armor that fired the shells. It was won by the logistics that carried them. And it was a battle that Wehrmacht Field Marshal Ewald von Kleist admitted Germany had lost, not to the T-34 tank but to an American transport vehicle, the Studebaker US6 truck. For decades, you have been taught that the war in the East was decided by armored clashes. History books focus on the tank battles of Kursk and the siege of Stalingrad. We are led to believe that tactical combat, armored thickness, and firepower are the sole variables of victory. But behind closed doors, Soviet leadership knew this was a myth. In a declassified 1963 wiretap, Soviet Marshal Georgy Zhukov admitted that without American trucks, the Red Army would have been paralyzed. The Wehrmacht did not lose to Soviet industrial dominance, they lost to American arithmetic. Albert Speer wrote in his memoirs that U.S. truck deliveries were of decisive importance to the Soviet advance. Wehrmacht logs confirm that German tactical planning was completely disrupted by the unexpected speed and mobility of Soviet divisions, which moved at rates Wehrmacht planners deemed mathematically impossible. In this video, we will examine the mechanical and logistical chess game of the Eastern Front. We will dissect how Germany's horse-drawn Blitzkrieg collapsed, how the Red Army resolved its transport crisis, and why a non-combat truck from Indiana became the most lethal vehicle of the war. Chapter 1: The Illusory Blitzkrieg, the thunder of rolling tracks, the roar of internal combustion engines, the swift, crushing advance across the Polish plains. Popular history has painted a vivid, permanent picture of the German war machine. We look at the opening years of the Second World War and we see a fully motorized, mechanical juggernaut. We see panzer divisions slicing through enemy lines, followed by fleets of high-speed transport trucks carrying infantry, fuel, and ammunition. We call it the Blitzkrieg. But this motorized illusion was a masterclass in propaganda, not a reflection of logistical reality. Behind the thin spearhead of armored vehicles lay a massive, prehistoric logistical tale. The German army did not conquer Europe on wheels. They marched on foot, and their supplies were dragged through the mud by animal power. When the German army launched Operation Barbarossa, the invasion of the Soviet Union in June 1941, they deployed 3 million soldiers. To support this massive force, they gathered over 600,000 vehicles. But these vehicles were a mechanical nightmare. They consisted of over 150 different truck models, sourced from civilian sectors across conquered Europe. There were French Renaults, Belgian trucks, and domestic German vehicles. Each of these models required custom spare parts, specific oil grades, and specialized maintenance tools. Consequently, the Wehrmacht's supply columns were a rolling museum of European automotive history. If a single axle broke on a captured French truck in the middle of Ukraine, the vehicle was abandoned because the spare parts were sitting in a depot in Paris, 2,000 miles away. Therefore, the German High Command had to rely on a more traditional form of transport: the horse. During the invasion of the Soviet Union, the Wehrmacht deployed over 750,000 horses. By 1943, that number had grown to over 2,700,000. The food they ate, the ammunition they fired, and the fuel their tanks consumed were carried on wooden wagons pulled by teams of draft horses. This reliance on animal power created a fundamental bottleneck. A horse-drawn supply column can travel at a maximum speed of 4 miles per hour. It requires tons of fodder daily, which takes up valuable space in the supply wagons. Therefore, the deeper the panzers pushed into Soviet territory, the further they drifted from their supplies. The armored tip of the spear was moving at 30 miles per hour, but the logistical shaft was crawling at 4. In his private diary entries, General Franz Halder, chief of the German General Staff, repeatedly expressed concern over this growing disparity. He noted that the Wehrmacht's tactical speed was entirely dependent on the physical limitations of draft animals. If a horse died of exhaustion, the ammunition wagon it pulled was left behind. By August 1941, Wehrmacht logistics officers were reporting a daily loss rate of over 1,000 horses across the entire front. To make matters worse, the Wehrmacht's truck fleet was breaking down at an alarming rate. The civilian vehicles seized in France and Belgium were not designed for the rough, dusty tracks of Russia. The fine dust of the Soviet steppes clogged rough carburetors, wore down piston rings, and destroyed crankshaft bearings within weeks. The lack of standardized oil filters and air cleaners meant that vehicles were suffocating in the dust. By the time the rains of the Russian autumn arrived in October 1941, the situation degenerated into a logistical catastrophe. The steppes transformed into the Rasputitsa, a sea of black clay so deep and adhesive that it literally pulled the boots off soldiers' feet. On these roads, the Wehrmacht's transport vehicles were utterly useless. Two-wheel-drive Opel Blitz trucks sank to their chassis, their tires spinning ineffectively in the sludge. The horses, forced to pull loads through mud that reached their bellies, died of heart failure and exhaustion. Indeed, entire infantry divisions were reduced to carving paths through the mud by hand, carrying supply crates on their shoulders. The German system of Blitzkrieg, designed for fast, motorized offensives, was strangled by the very soil it sought to conquer. The strategic lesson was brutal. Tactical combat is an illusion if the vehicles carrying the supply line cannot overcome the geography of the battlefield. Chapter 2. The Relocation and the Void. As the German armed forces advanced deeper into Soviet territory, the Soviet Union faced an industrial disaster of unprecedented scale. Within the first 6 months of the war, the German army occupied or isolated regions that produced over 60% of the Soviet Union's coal, 70% of its pig iron, and 80% of its aluminum. Critically, the vast automotive manufacturing hubs in Moscow, Gorky, and Kharkov were either destroyed, captured, or forced to halt production as infantry fighting reached their gates. The Soviet Union was threatened with a complete loss of its motorized transport industry. In response, Stalin's State Defense Committee, the GKO, issued an extraordinary command: the complete evacuation of Soviet heavy industry to the east. In an unprecedented logistical feat, entire factories were disassembled, piece by piece. Lathes, presses, power generators, and assembly lines were loaded onto thousands of railway cars and shipped eastward, deep into the Ural Mountains and Siberia. The conditions at these new eastern sites were grim. In the winter of 1941 and 1942, factory workers, many of them women and teenagers, assembled machinery in open-air fields under sub-zero temperatures. Before the roofs of the factories were even built, the machinery was operational, running on temporary power grids. But the GKO faced a severe shortage of raw materials and laborers. Therefore, they made a decisive strategic decision. All Soviet industrial capacity was directed toward the production of armor, artillery, and combat aircraft. The Soviet Union committed its steel to the T-34 tank and the Ilyushin II-SH Sturmovik fighter. They stopped the production of military transport trucks. Domestic Soviet truck factories were ordered to convert their assembly lines to build light tanks and rocket launchers. The few trucks that were produced were crude, stripped-down machines designed to save material. The standard Soviet truck of the 1930s, the GAZ-A, was simplified. The wooden cabin was replaced with a canvas roof, the metal doors were replaced with canvas flaps, and the front brakes were removed entirely to conserve precious copper and steel. This vehicle, the GAZ-AA, was underpowered and unstable, carrying a maximum load of only 1.5 tons. The larger ZIS-5 was slightly more robust but lacked all-wheel drive, mechanical reliability, and off-road mobility. This created a fatal tactical void. The Red Army was building thousands of T-34 tanks, but they had no transport fleet to support them. A tank engine consumes hundreds of gallons of fuel every few hours, and a tank brigade fires tons of ammunition in a single engagement. Without trucks, these tanks were stranded. During the Soviet counteroffensives of the winter of 1941 and 1942, the Red Army broke through German lines, but could not exploit their victories. Their infantry had to march on foot through deep snow, carrying their ammunition on their backs. Their artillery was pulled by slow civilian tractors or horses, which quickly died in the extreme cold. Consequently, Soviet advances stalled within days of a breakthrough. The The Wehrmacht, utilizing internal railway lines and tactical redeployment, could easily cut off the overextended, slow-moving Soviet vanguard. The Red Army possessed the armored fist to break the German shield, but they lacked the mobility to sustain the blow. Without wheels, their tactical successes were doomed to remain temporary, localized events, unable to alter the strategic map of the Eastern Front. Chapter 3. The Steel Lifeline. The resolution of the Soviet Union's logistical crisis did not originate in Siberia. It came from the conveyor belts of Detroit and the port cities of the United States. Under the Lend-Lease program, the United States committed its immense industrial capacity to supply the Allied nations, recognizing that the defeat of Nazi Germany demanded a global coalition of material. Delivering this lifeline to the Soviet Union was an operational nightmare. The Soviet Union was literally encircled by Axis powers or impassable geography. The Allies had to construct 3 distinct transit corridors, each requiring massive engineering resources and facing extreme military hazards. The first corridor was the Arctic Convoys. Ships departed from ports in Great Britain and Iceland, navigating the cold waters of the Barents Sea to reach Murmansk and Arkhangelsk. This route was the shortest, but it was a gauntlet of death. The convoys sailed past the coast of occupied Norway, where German U-boats, destroyers, and Luftwaffe bombers were waiting. Convoy PQ-17, sailing in July 1942, became a symbol of this danger. After being scattered by air and submarine threats, 24 of its 35 merchant ships were sunk, depositing thousands of trucks and planes at the bottom of the ocean. The second corridor was the Pacific route. Soviet-flagged ships carried supplies from Portland and Seattle across the Pacific to Vladivostok. Although Japan and the Soviet Union were not at war, Japanese naval patrols constantly intercepted and inspected these vessels, and the Arctic ice conditions of the Sea of Okhotsk delayed shipments for months. Once the cargo landed in Vladivostok, it faced a 5,000-mile journey on the Trans-Siberian Railway to reach the front lines in the west. The railway infrastructure was overloaded, and supplies taking this route took up to 3 months to arrive. The third and most successful pipeline was the Persian Corridor. Cargo was shipped around the Cape of Good Hope to the Persian Gulf. British and American forces occupied Iran in 1941 to secure this route. American engineers rebuilt the Trans-Iranian Railway and constructed massive highways through the Zagros Mountains. At assembly plants in Andymsk and Abadan, American automotive companies set up assembly lines in the desert. Boxed automotive components were assembled into completed trucks by local laborers supervised by U.S. Army officers. These vehicles were then loaded with ammunition and driven north through Iran into Soviet Azerbaijan. Through the Persian Corridor alone, over 180,000 trucks were delivered. In total, the United States shipped over 400,000 trucks, 50,000 jeeps, and 80,000 utility vehicles to the USSR. This was not a minor addition, it was an industrial invasion of wheels. The Red Army was mounted on American axles, breaking the tyranny of the logistical void. Chapter 4. The anatomy of a legend. Among the hundreds of thousands of American vehicles delivered to the Russian front, the Studebaker US6 became a legend. The vehicle was designed by the Studebaker Corporation of South Bend, Indiana, an established automotive manufacturer that had once built wooden wagons for the Union Army during the American Civil War. The Studebaker US6 was a 2.5-ton truck designed from its conception for military service. It was constructed to be extremely durable, simple to repair, and capable of operating in the most extreme climatic conditions on Earth. The engine was the Hercules JXD, a 6-cylinder, liquid-cooled gasoline engine that produced 95 horsepower. This engine was famous for its simplicity and reliability. It was a low-compression engine, which proved to be critical on the Eastern Front. It could run on the low-grade, low-octane gasoline produced by Soviet refineries, which would have destroyed more complex American engines. The vehicle's drivetrain was a 6x6 system, transmitting power to all 6 wheels. It featured a 2-speed transfer case and a 5-speed manual transmission, giving the driver 10 forward speeds. This allowed Soviet drivers to shift into the lowest gear range to gain maximum torque when crossing deep mud or swampy terrain. The suspension was constructed of heavy-duty leaf springs and reinforced steel axles. The frame was built from cold-rolled steel channels, providing exceptional structural strength. Although its official military rating was 2.5 tons, Red Army logistics officers regularly loaded the Studebaker US6 with up to 5 tons of supplies. Another critical design element was the use of standard dual rear wheels with deep-tread tires. This distributed the weight of the vehicle over a larger area, preventing the truck from sinking in soft soil. It literally floated on top of the mud that strangled the German Opel Blitz. Furthermore, the Studebaker featured vacuum-assisted hydraulic brakes on all 6 wheels. This proved to be a decisive operational advantage when towing heavy artillery pieces through the Caucasus Mountains. Soviet drivers could maintain complete control of their heavy cargo, even on icy, narrow mountain passes. The Soviet soldiers called the truck the Studer, and it became a symbol of reliability. While Soviet trucks constantly broke down due to weak axles and substandard metal castings, the Studebaker ran without interruption. It brought standardization to the Soviet logistical network, saving the Red Army from the logistical chaos that doomed the German Blitzkrieg. Chapter 5. The Schutanskoot Metamorphosis, the weapon that defined the terror of the Eastern Front, did not make a sound until it was too late. The Soviet BM-13 rocket launcher, known to the Red Army as the Katyusha and to the Germans as Stalin's organ, was a devastating psychological and physical force. A single battery of 4 Katyusha launchers could unleash a salvo of 64 rockets in under 10 seconds. The sheer volume of high-explosive payloads saturated an entire grid zone, shredding infantry positions, destroying light armor, and shattering the morale of even the most battle-hardened Wehrmacht divisions. But in the early years of the war, this tactical brilliance was severely limited by a mechanical bottleneck. The launcher system was originally mounted on the Soviet-built ZIS-6 truck, a 3-axle, 2-wheel drive vehicle that was structurally inadequate for the task. The ZIS-6 was underpowered, heavy, and lacked the suspension strength to absorb the immense recoil of a rocket launch. The engine, a plodding 73-horsepower motor, coupling with a crude 4-speed transmission, was utterly incapable of propelling the severe weight of the launcher system over difficult terrain. The launch ramp itself, known as the BM-13 rail assembly, consisted of 8 steel I-beams that were 8 feet long, supported by a heavy tubular steel subframe. This structure weighed over 2 tons. When mounted on the ZIS-6, it pushed the vehicle's center of gravity dangerously high. Consequently, during translational movement across uneven fields, the trucks tended to roll or sway in a dangerous manner. On steep mountain roads or swampy swales lacking 4-wheel drive, the rear dual wheels of the ZIS-6 slipped constantly, swallowing up precious fuel and stranding the weapon system. More critically, the recoil of a salvo launch was immense. Indeed, each rocket weighed over 90 pounds. As the rocket motor ignited, the forward propulsion generated vast dynamic loads that were transmitted directly through the launch rails into the truck's frame. The frame of the ZIS-6, fabricated from poor-quality Soviet spring steel, bent and warped under the force. The leaf springs collapsed and the housings of the rear axles cracked. To prevent the chassis from buckling entirely, Soviet engineers had to install manual screw jacks at the rear of the truck. Before the launcher could fire, the crew had to dismount, unfold the screw jacks, and crank them down by hand to lift the weight of the vehicle off the axles. This crude workaround secured the vehicle during the launch, but it created a deadly strategic delay. When the Katyusha fired, the infernal rocket plumes generated a colossal cloud of white smoke and dust that could be seen from miles away. Thus, coupling with the deafening scream of the ignition, the launch position was instantly revealed to German spotters. German counter-battery procedures were efficient. The Wehrmacht utilized the 10.5 cm light field howitzer and the Nebelwerfer rocket system to zero in on detected firing plots within 3 to 4 minutes of a launch. Once a salvo had been deployed, the Soviet crew had to immediately escape. But on the ZIS-6, this was a dangerous operation. Indeed, the crew had to retract the screw jacks, crank them up by hand, get back into the cabin, and coax the underpowered engine to life. If the mud season was active, the trucks spun their tires, stranded in the bomb craters created by their own launch influence. As a consequence, Soviet rocket artillery losses in 1941 and 1942 were extraordinary, not to enemy tactics but to logistical immobility. Therefore, the Red Army's High Command ordered a radical re-engineering campaign. They mounted the BM-13 Katyusha rails directly onto the rugged chassis of the imported American Studebaker US6. The results were revolutionary. The Studebaker's all-steel frame and robust suspension system were so exceptionally strong that they could absorb the dynamic loads of a salvo without chassis distortion. The truck's 6x6 transmission and Hercules engine allowed it to enter difficult forest positions without requiring constant preparation. The Studebaker could drive into a muddy swale, launch its 64 rockets, and escape immediately. The screw jack workaround was largely bypassed or speedily handled, allowing the crew to execute shoot-and-scoot encounters in under 19 seconds. The rocket batteries could fire, accelerate to 30 miles per hour, and move 5 miles away before the first German artillery shells exploded in the empty launch field. Diaries of Soviet rocket operators preserved the emotional shift in the crews. They noted that the Studebaker was a palace compressed into a machine. Indeed, unlike the drafty wooden cabin of the ZIS-6, which lacked a heater and let in freezing wind, the Studebaker cabin was all steel, insulated, and featured a heating system that kept the operators warm in the middle of winter. The crews adored the Studebaker not just for its operational supremacy, but for the protection it offered. The American chassis secured the majesty of the Katyusha, converting a fragile and vulnerable system into the first truly mobile rocket system in the history of combat. Chapter 6: Operation Bagration and the Deep Battle, June 1944. 3 years after the invasion of the Soviet Union, the Red Army was prepared to unleash Operation Bagration. This was not a traditional defensive engagement. It was an operational storm designed to destroy the Wehrmacht's Army Group Center in Belorussia. The doctrine of deep battle, pioneered by Soviet theorists like Vladimir Tryandafilov in the 1930s, mandated that defensive front lines must not only be broken, but penetrated continuously. The objective was the total strangulation of the enemy's command network, the destruction of their supplies, and the annihilation of their reserves before they could retreat. But deep battle required rapid operational movement. To execute this doctrine, Soviet Army Corps had to advance 30 to 40 miles a day, bypassing encircled German cities and striking choke points far behind the lines. This demanded an immense transport infantry capability. If the infantry had to march on foot, the tanks of the vanguard would advance alone, leaving them isolated and subject to Wehrmacht tank counterattacks. The Studebaker US6 reorganized the operation. By 1944, the Red Army had motorized entire rifle divisions, engineer regiments, and artillery sectors on American tires. When the Soviet armored forces shattered the German front lines in Belorussia, the motorized infantry followed immediately. They traveled at continuous convoy speeds, securing the flanks of the tanks and capturing strategic highways and river crossings. The Belarusian geography was a maze of dense forests, swamps, and roadless marshes. German planners calculated Soviet offensive velocity based on traditional horse-drawn variables. They assumed that the swampy swales would prevent the Red Army from moving heavy artillery and infantry units in cohesion. Therefore, the Wehrmacht command expected to have several days to retreat behind the Berezina River and establish defensive lines. But they had calculated the equation wrongly. The Soviet motorized column, powered by the Studebaker, traversed the roadless forest paths with ease. Indeed, the truck's 6x6 suspension allowed it to pull the heavy howitzers directly through the swamps. The Red Army captured the Berezina bridgeheads long before the retreat of the German 4th and 9th Armies was even complete. The entire Wehrmacht retreat path was cut off, trapping Army Group Center in a massive strategic pocket. The result was an unparalleled tactical disaster. In less than 7 weeks, the German Army Group Center was almost completely annihilated. 28 out of 34 Wehrmacht divisions ceased to exist. Over 400,000 German soldiers were killed, wounded, or taken captive. To demonstrate the utter destruction of the German center to the world, Stalin ordered a massive parade. On July 17, 1944, 57,000 German prisoners of war, including 19 generals, marched through the streets of Moscow under the gaze of silent Soviet crowds. This massive military collapse proved the victory of deep battle logistics. The Wehrmacht had been outrun, outorganized, and outmaneuvered by an army mounted on Studebaker wheels. The Blitzkrieg doctrine had been turned back on its creators, not by a better combat tactic, but by the sheer logistical horsepower of American engines. Chapter 7. The Post-War Reckoning. In the immediate aftermath of the Second World War, the map of Europe was redrawn, and a thick Cold War silence fell between the Soviet Union and its former Western allies. Strategic cooperation was instantly replaced by geopolitical competition, and both nations began a critical campaign to rewrite the narrative of the victory. For Soviet historians and propagandists, acknowledging that the defeat of Nazi Germany had depended on American industrial capitalism was ideologically unacceptable. The Red Army was depicted as an unstoppable force that had crushed the Wehrmacht solely through the superiority of the socialist economic model and the sacrifice of the Soviet people. The native history textbooks committed entire chapters to the industrial output of the Ural factories, celebrating the workers who built the T-34 tanks and the Yak fighters. But they conveniently erased the rolling infrastructure of Detroit. Lend-Lease aid was officially dismissed in state documentaries as a minor injection, accounting for only 4% of total Soviet domestic manufacture. But this 4% narrative was a mathematical legerdemain. Indeed, while the total tonnage of Lend-Lease cargo was a small fraction of Soviet coal or raw ore tonnage, its specific value in high-technology infrastructure, particularly in motorized transportation, aviation fuel, and telecommunications equipment, was almost 100% decisive. Stalin himself recognized this truth during the Tehran Conference in 1943. In a declared toast to U.S. President Franklin Roosevelt, Stalin remarked, "The United States is a country of machines. Without the use of those machines through Lend-Lease, we would lose this war." But as the shadow of the Cold War lengthened, such honesty was declared revolutionary treason. Soviet citizens who spoke of American trucks were arrested, and private diaries mentioning Lend-Lease aid were destroyed by state censors. Yet the declassified records of the Soviet state archives revealed a private desperation in the highest command sectors. In a 1963 KGB wiretap transcript of a private residence conversation, Marshal Georgy Zhukov uttered words that would have condemned an average citizen to Siberia. Zhukov remarked candidly, "Now they say the Allies never helped U.S., but it cannot be denied that the Americans sent U.S. so many materials, without which we could not have formed our reserves and could not have continued the war. We had no explosives, no gunpowder, we had nothing to load our cartridges with. The Americans drived over sheet steel to U.S. How could we set up tanks production so rapidly if not for the help with metallurgical steel and without the Studebakers? We would have had nothing to pull our guns on. They largely solved our front-line mobility." This private verdict was support. Ed by Nikita Khrushchev in his memoirs, he wrote, "I must state frankly that if the United States had not helped U.S., We would not have won the war. Our logistical infrastructure would have collapsed entirely, and our forces would have been surrounded and annihilated by the mobile German units. Asterisk on the opposing side of the front line. The Wehrmacht command came to the same realization. In post-war interrogations with the U.S. Army Historical Division, General Franz Halder admitted that German strategic calculations failed repeatedly in 1943 and 1944 because Wehrmacht intelligence constantly miscalculated Soviet offensive depth. Halder explained that in traditional European doctrine, an infantry force retreating before a fast-moving panzer army could not regroup quickly. But the Soviets were moving complete armies on Studebakers. Entire infantry divisions were trucked around German flanks at night, re-establishing secure front lines in places where the German staff expected no enemy forces for days. Field Marshal Ewald von Kleist, commander of German panzer forces in South Russia, recorded a similar verdict in captivity. He stated, "Asterisk, the Soviets did not defeat U.S. by superior tactical combat. They defeated U.S. because their logistical trucks outrun our draft horses. We spent days caring for horses and repairing 100 different civilian trucks, while the Red Army drove standardized American machines directly across the roadless steppes." Asterisk, the war on the Eastern Front was an operational truth test. The Wehrmacht attempted to run a modern war on a prehistoric animal logistics base. Conversal. Why the Soviet Union, backed by the arithmetic of American industrial factories, motorized its frontline infrastructure. In the calculus of war, mobility and reliable logistics will always triumph over tactical armor and force design. Chapter 8, The Persian Corridor, Saga. The vehicles that decided the war did not begin their journey in Russia. They began their journey in the manufacturing hubs of Detroit, South Bend, and Flint. In the United States, completed trucks were disassembled and packed into massive wooden containers known as completely knocked down, or CKD, kits. This packaging process was a masterpiece of industrial logistics. By shipping the trucks as compact component kits rather than fully assembled vehicles, the United States Navy could load 4 times as many units onto the cargo holds of Liberty ships. These Liberty ships departed from East Coast ports, embarking on a 12,000-mile voyage around the Cape of Good Hope, crossing the Indian Ocean to enter the warm waters of the Persian Gulf. They landed at the ports of Abadan, Khorramshahr, and Bandar Shapur. In 1941, these ports were crude, underdeveloped harbors lacking heavy cranes and modern railways. Therefore, British and American engineering units launched a massive harbor construction campaign. They built deepwater concrete piers, erected giant steam cranes, and laid hundreds of miles of rail tracks to connect the ports to the Trans-Iranian Railway. To assemble the thousands of incoming CKD kits, General Motors and the Douglas Aircraft Company established giant assembly plants in the Iranian desert at Andimshk and Abadan. These plants were industrial cities, erected in the middle of a barren landscape. The assembly lines operated 24 hours a day under extreme environmental conditions. In the summer months, the temperature in the assembly halls exceeded 120 degrees Fahrenheit. The metal tools became so hot that the workers had to wear thick leather gloves to handle them. Dust storms swept through the open bays, clogging engine cylinders and painting the wet paint of newly assembled cabins with yellow dust. The labor force was a diverse mix of American military engineers, British mechanics, and thousands of local Iranian laborers. Working together, they achieved an extraordinary rate of assembly, churning out up to 200 completed Studebaker and Dodge trucks every single day. Once a truck rolled off the assembly line, it was loaded with critical cargo, such as industrial machinery, copper ingots, or ammunition crates, and delivered to the drivers of the U.S. Army's Motor Transport Service. This was the start of the Persian Corridor highway route, a dangerous 600-mile mountain road crossing the Zagros Mountains into Soviet Azerbaijan. The mountain highway was a terrifying path of narrow, single-lane roads carved into sheer rock cliffs. The passes reached altitudes of over 9,000 feet, where the thin air reduced engine horsepower and caused coolant systems to boil. In the winter, the passes were blocked by snowdrifts, and sheet ice turned the roads into slide hazards. The drivers had to navigate these routes in massive convoys of up to 100 trucks, driving without headlights at night to avoid sabotage. If a truck slipped off the edge, it fell thousands of feet into the rocky ravines below. Many drivers and mechanics died of hypothermia, heat stroke, or traffic accidents. At the Soviet border town of Julfa, the trucks were met by Soviet acceptance officers. These inspectors were notoriously strict. They checked every screw, every fluid level, and every spare tire against the shipping manifests. If a single tool was missing from the vehicle's standard toolkit, the truck was rejected until the Americans could provide a replacement. Once accepted, the Soviet drivers climbed into the cabins and drove the vehicles north through the Caucasus Mountains into the combat zones of southern Russia. Through the Persian Corridor, the United States delivered over 180,000 vehicles. This desert highway, carved through sand and rock, was the logistical artery that pumped the industrial blood of America directly into the heart of the Red Army. Chapter 9. The technical duel of standardization. The war in the East was a mechanical duel, not just between tanks, but between two opposing logistical philosophies. Nazi Germany approached the problem of infrastructure with tactical individualism and engineering complexity. Conversely, the United States and the Soviet Union logged the war with standardization and industrial scale. This disparity is seen in a direct tactical comparison between the primary transport workhorses of both armies, the German Opel Blitz and the American Studebaker US6. The Opel Blitz was the backbone of the Wehrmacht's fleet. Constructed by Opel, a German automotive company seized and directed by the Nazi state, the truck was a 3-ton vehicle. In traditional civilian environments, it was an excellent machine, light, rapid, and featuring a smooth engine. But it was constructed as a 4x2 vehicle, meaning power was delivered only to the two rear wheels. Although the Germans developed a 4x4 all-wheel drive version, the Opel Blitz Allrad, production limitations meant it was deployed in trivial numbers compared to the frontline demand. Consequently, the Wehrmacht operated in an environment of logistical fragmentation. When entering the swampy forest or the mud steppes of Russia, the rear-wheel drive Opel Blitz vehicles slipped and sank. To move an infantry column, German soldiers had to constantly dig out stuck vehicles or rely on horse teams to pull them from the holes. The mechanical disaster was magnified by the diversity of the Wehrmacht fleet. To sustain their mobility, German units seized thousands of civilian trucks from occupied France, Belgium, Holland, and Denmark. This created an insurmountable spare parts nightmare. Wehrmacht repair depots had to maintain separate inventories for Renault, Citroën, Peugeot, Ford of France, and Opel vehicles. Each model had a different drive shaft length, different cylinder displacements, different thread pitches on its bolts, and unique rim sizes. Indeed, even the wheel bolts were not standardized. A German mechanic encountering a Citroën truck with a seized gearbox had to abandon the vehicle because he had no gear replacements that would fit the housing. Furthermore, German steel metallurgy during the later war years was crippled by a shortage of nickel, chromium, and manganese. As a result, German drive shafts and axles were fragile. In sub-zero winter temperatures, the brittle carbon steel axles of the Opel Blitz cracked under critical loads. Conversely, the Red Army standardized its driver system around the Studebaker US6. Indeed, although they also received Dodge and Chevrolet trucks, the Studebaker comprised the bulk of the frontline logistical trucks. The Studebaker was built from high-quality cold-rolled steel channels, reinforced with vanadium and nickel alloys. Under the severest cold of Siberian winds, the frame maintained its flexibility, bending rather than cracking under extreme loads. The motor was standardized. The Hercules JXD engine used identical spark plugs, cylinder gaskets, pistons, and valves across all 152,000 vehicles. Any Soviet mechanic could repair any Studebaker on the field using a single standardized wrench set and spare components marked with American serial numbers. The tires of the Studebaker were standardized across the entire fleet. The 10-ply dual rear wheels used identical bolt holes and rim dimensions. If a Studebaker blew a tire, the crew could easily salvage a wheel from any abandoned American truck in the area and mount it within 19 minutes. The power distribution was an engineering masterpiece. The Studebaker sent torque to all 6 wheels, distributing the load over a vast surface area. In swampy fields where the Opel Blitz sank instantly, the Studebaker rolled continuously. The decisive victory of the Studebaker was a victory of logistical arithmetic. The United States and the Soviet Union realized that a single, standardized, rugged machine produced in massive numbers is indeed far superior to a diverse fleet of delicate, complex machines. The Opel Blitz was an engineering piece of civilian perfection. The Studebaker was an industrial engine of war. Chapter 10: The Logistical Legacy in Modern Conflict. The strategic lessons of the logistical duel on the Eastern Front reverberated far beyond the Second World War, shaping the doctrine of modern military forces and challenging classical theories of warfare. For centuries, military writers had emphasized the majesty of tactical combat. They celebrated the genius of generals who could outmaneuver the enemy on the field, or the bravery of soldiers who charged defensive perimeters. They looked at war as an art form, decided by character and combat doctrine. But the Eastern Front demonstrated that in the era of industrial total war, tactical combat is a subordinate variable. As the geopolitician Hale Halford Mackinder warned, the nation that controls the vast geographical resources of the heartland can only be conquered by a nation capable of sustaining an endless logistical pipeline. The true heroes of the Red Army offensives were not the tanks, but the supply convoys. Indeed, the T-34 tanks captured German cities, but it was the Studebaker trucks that carried the steel bridge plankings, the telephone lines, the fuel drums, and the howitzer shells that enabled those victories. The legacy of the Studebaker can be seen in the post-war evolution of Soviet military vehicles. When Soviet engineers returned to their factories after 1945, they designed their new fleets of trucks around the blueprints of the Studebaker US6. The famous Soviet ZIL-151 and the later Ural 375 trucks, vehicles that powered the logistical system of the Warsaw Pact during the Cold War, were direct mechanical descendants of the American Studebaker. They coupled the 6x6 drivetrain, the suspension geometry, the tire configuration, and the simplicity of the engine compartment. The Studebaker had inoculated the Soviet military with a permanent respect for standardization and off-road mobility. While Western armies continued to experiment with complex automotive systems, the Soviet Union maintained a strict doctrine of motorized infrastructure, ensuring that every truck could be repaired by an unskilled conscript with basic tools. In the final summation, the story of the Studebaker on the Eastern Front challenges the viewer to re-evaluate the narrative of World War II. The war was not won solely by armored thickness, bullet calibers, or ideological fanaticism. It was won by industrial standardization, geopolitical alliances, and the massive transportation networks that connected the assembly lines of Indiana to the ruins of Berlin. The bulldozer and the truck were indeed the true decisive weapons of war, proving that in the theater of total conflict, the arithmetic of transport will always conquer the myth of tactical perfection. Chapter 11: The Arctic Convoy Gauntlet. The steel pipeline that propelled the Soviet advance was forged in the freezing waters of the North Atlantic. While the Persian Corridor was a desert triumph, the Arctic Convoys were a saga of maritime slaughter. The merchant sailors who manned the Liberty ships and cargo vessels departing from Hvalfjordur in Iceland and Loch Ewe in Scotland were civilians. Yet they faced an operational gauntlet that rivaled the worst horrors of the frontline trenches. The naval commanders of both sides recognized the decisive value of the route. For Admiral Erich Rieder, commander of the German Navy, strangulating the Arctic Lifeline was the highest priority. The Wehrmacht deployed a powerful combat fleet to occupied Norway, including the battleship Tirpitz, the heavy cruisers Admiral Scheer and Lutzow, and flotillas of U-boats. In the air, the Luftwaffe's 5th Air Fleet operated over 300 bombers and torpedo planes from base positions in Banach and Kirkenes. For the Allies, protecting the convoys demanded a massive naval commitment. Admiral John Tovey, commander of the British Home Fleet, had to coordinate close escort groups of destroyers and corvettes coupling with distant covering forces of battleships and aircraft carriers. But the geography of the Arctic was a cruel ally to the Germans. In the summer months, the region experienced 24 hours of daylight, eliminating the protection of night cover. Convoys were forced to sail along the edge of the polar pack ice, leaving them constantly visible to German reconnaissance aircraft. The tragedy of Convoy PQ-17 demonstrated the extreme friction of this route. Departing in June 1942, the convoy carried 297 aircraft, 597 tanks, and over 4,000 trucks. On July 4, 1942, the British Admiralty received reports that the Tirpitz had departed its fjord position. Fearing the giant battleship would annihilate the escort force, the First Sea Lord Admiral Dudley Pound issued the fateful command, * convoy is to scatter. * the defensive cohesion of the convoy was shattered. The merchant ships, left without destroyer escort, sailed as individual targets through the ice fields. The Luftwaffe and the U-boats launched a methocidal attack. For 7 days, the cold Arctic waters reverberated with explosions. Out of 35 merchant ships, 24 were sunk. Over 3,000 trucks, 700 tanks, and 210 planes deposited at the bottom of the Barents Sea. Only 11 ships reached Arkhangelsk. Yet the lifeline could not be cut. The Allies reorganized the convoys. In September 1942, Convoy PQ-18 sailed with a heavily reinforced escort, including the escort carrier HMS Audacity. Although the Germans launched devastating torpedo runs, the defensive network held. 13 merchant ships were lost, but 27 arrived safely in the northern ports, unloading thousands of completed trucks and raw materials. The unloading process in Murmansk and Arkhangelsk was an operational triumph of human endurance. The ports were constantly targeted by German bombers. The dockworkers, primarily Soviet women and refugees, operated in temperatures reaching 40 degrees below zero. The steel cranes were frequently frozen solid, demanding that the workers build wood fires around the gears to melt the ice. The merchant ships were unloaded under the glow of fluorescent shells and incandescent fires, as the German air raid sirens wail constantly. The crates containing the Studebakers were assembled in improvised outdoor shops. The mechanics, working without heating and with lubricants that froze into solid clays, assembled the drive shafts, mounted the wheels, and fueled the engines. The drivers then headed south along the ice roads, navigating through snowstorms and German air attacks to reach the combat zones. The Arctic convoys were a monument to human will, proving that in the heavy calculus of war, the logistics of cargo will always survive the weapons of destruction. Chapter 12. The Vladivostok Trans-Shipment and the Siberian Express. While the northern sea routes were battles of maritime survival, the Pacific Corridor was a strategic silent run. The ships departing from Portland, Seattle, and San Francisco carried logistical blood to the Soviet Union through the port of Vladivostok. Because the Soviet Union maintained a neutrality pact with the Imperial Japanese Empire until August 1945, these ships sailed under the Soviet flag. They carried civilian crews and were officially prohibited from carrying weapons of war. But the cargo holds of the Siberian Express, as the sailors called the fleet, were packed with the industrial materials that enabled the Soviet military-industrial complex. They carried railway locomotives, cold-rolled steel sheets, aviation gasoline, raw copper, and thousands of completed Lend-Lease vehicles. The Japanese Navy constantly intercepted and inspected the Soviet cargo vessels in the Tsugaru Strait and the Sea of Japan. Japanese officers climbed aboard the ships, examining SHP ping manifests and prying open wooden containers to search for contraband weapons. The Soviet crews had to hide the military value of the cargo. Studebaker trucks were officially registered as agricultural utility machines, and jeeps were labeled light forestry vehicles. If a Japanese inspector discovered rocket artillery components or military radios, the ship was seized and the cargo confiscated. Consequently, the Siberian Express route demanded a constant diplomatic dance, with Soviet and American officials maintaining a strict deception to keep the flow of wheels moving. Once the cargo landed at the port of Vladivostok, it faced a severe logistical bottleneck. The vehicles and industrial material had to be shipped across the 5,000-mile length of the Trans-Siberian Railway to reach the combat zones in the west. The Soviet rail infrastructure in 1941 was unprepared for this volume of transport. The locomotives were obsolete, the coal reserves were limited, and the gauges of the rails were different from European standards. Therefore, the United States shipped over 1,900 locomotives and 11,000 cargo rail cars to the Soviet Union. Among these, the Alco RSD-1 diesel-electric locomotive, built in Schenectady, New York, played a critical role. These locomotives were shipped as completed units, mounted on the decks of cargo vessels. Once landed, they were directed to pull the heavy Siberian Express trains across Siberia. The trains carried thousands of Studebaker kits, driven by Siberian engineers who maintained a continuous tempo, running the locomotives without pause by shifting crews on the move. At intermediate rail siding places, the Studebakers were assembled directly on flatbed rail cars. The mechanics worked in the middle of Siberian winter winds, mounting wheels and engines while the trains were parked in remote sidings. Once assembled, the trucks were loaded with cargo and driven off the rail cars using improvised wooden ramps. They then hooked up with logistical columns in central Russia, driving hundreds of miles to reach the front lines. The Pacific Route and the Siberian Express defeated the tyranny of the logistical void. Through covert diplomacy, industrial locomotives, and the majesty of railroad engineering, the Allies mobilized the Red Army, proving that in geopolitical warfare, the arithmetic of transport will always overcome the resistance of barriers. Chapter 13. The Battle of Stalingrad and the Volga Lifeline, the strategic turning point of the war on the Eastern Front, is celebrated in popular history as a battle of urban endurance. We see the ruins of the tractor factory, the grain elevator, and the basement of the department store where General Friedrich Paulus surrendered. We are told that Stalingrad was won by the tenacity of General Vasily Chuikov's 62nd Army, who clung to the ruins on the west bank of the Volga River, exchanging life for seconds of combat. But coupling with this endurance was a logistical flow of extreme asymmetry. The ruins of Stalingrad were a defensive anvil, but the Soviet logistical pipeline on the east bank of the Volga was the hammer that crushed the Wehrmacht. The geography of Stalingrad was a logistical trap for both armies. The Volga River, a vast and swift waterway over a mile wide, separated Chuikov's infantry from their primary supply lines. Every bullet, every shell, and every draft of reinforcements had to be trans-shipped across the river from the east bank under constant German artillery and air attacks. The east bank of the Volga was a flat, roadless steppe. The Soviet railheads were located hundreds of miles behind the lines. The Red Army had to transport thousands of tons of cargo daily from these rail junctions to the river crossing places. This is where the motorized strength of the Red Army, powered by Lend-Lease trucks, became the decisive factor. The Soviet transport group standardized their operations around the Studebaker US6 and the Dodge 3/4-ton truck. These trucks operated in a continuous loop. They carried shells, fuel, and bread from the railway junctions, traversing the muddy, sandy tracks of the steppes to reach the Volga landing areas. The intensity of the convoy encounters was staggering. In the autumn of 1942, the Soviet Motor Transport Service operated over 10,000 trucks in the Stalingrad sector alone. The rugged Studebakers, towing heavy field artillery pieces and loaded with ammunition, traversed the roadless marshes of the Volga basin with ease. Their 6x6 suspensions allowed them to deflect the geographical barriers that would have strangled the German Opel Blitz. When the ice conditions on the Volga River became stable in December 1942, the Soviet engineers built ice bridges. They laid wooden planks directly on the ice and reinforced the river crossings with steel frames. The Studebakers, overloaded with up to 5 tons of ammunition, drove directly across the frozen river, supplying Zhukov's forces on the west bank without requiring boats. Conversely, the German Sixth Army within Stalingrad faced a logistical collapse. The Wehrmacht's supply lines were crippled by horse starvation. Indeed, the area lacked fodder, and the German soldiers were forced to slay and eat their transport animals to survive. The German truck fleet was immobilized by engine freezing and a total lack of spare parts. Opel Blitz vehicles were stranded in the snow drifts, their carburetors clogged and their axles brittle. Hermann Göring's Luftwaffe attempted to establish an air bridge to supply the Sixth Army, promising to deliver 300 tons of cargo daily. But the air operations were a disaster. The Junkers 52 transports were shot down by Soviet fighters or destroyed on the ground by mobile Soviet troops mounted on Studebakers. The average German deliveries collapsed to less than 80 tons a day. The Sixth Army was strangled, starving, and out of ammunition. The surrender of Friedrich Paulus was the logical consequence of a logistical collapse. The Red Army had kept the Volga pipeline flowing with American wheels, while the Wehrmacht's animal power froze to death. Chapter 14. The Caucasus Petroleum Race and Case Blue. While Stalingrad was a clash of urban defense, the Caucasus campaign was a strategic race for liquid gold. In the summer of 1942, Adolf Hitler launched Case Blue, a massive strategic offensive designed to seize the Soviet oil fields of Makup, Grozny, and Baku. The Wehrmacht faced a critical oil shortage. Hitler explicitly warned his generals, "If we do not seize the oil of Baku, we must end the war." The task was committed to Field Marshal Ewald von Klest's Army Group A, a powerful armored force designed to offensive rapidly across the dry steppes of the Caucasus. Von Klest's panzers advanced with instant success. By August 1942, they captured Makup and reached the gates of Grozny. But the deeper they advanced, the more devastating their logistical friction became. The geography of the Caucasus was a maze of mountain passes, deep ravines, and roadless gullies. The Wehrmacht's supply corridors were stretched over 700 miles from their railheads in Rostov. The German motor fleet could not cope. The diverse fleet of French and Belgian trucks sank in the Caucasus dust, their engines failing due to air filter clogging. More critically, the Caucasus region lacked vegetation and fodder. The horses of Army Group A, forced to drag supply carts across the bare mountains, died of starvation. By October 1942, von Klest's forces were immobilized by the logistical squeeze. But the Red Army utilized a different solution. The Soviet Trans-Caucasus front was reinforced by the Persian Corridor deliveries. Studebaker and Dodge trucks, assembled in Iran, drove north through the Zagros Mountains directly into the combat zones of Georgia and Azerbaijan. These vehicles were mounted on deep-tread tires and had 6x6 transmissions, allowing them to navigate the narrow mountain roads with heavy loads. They carried fuel, ammunition, and reinforcements directly to the high mountain passes. The Soviet Trans-Caucasus infrastructure was mobile. While the Wehrmacht panzers were stranded due to lack of fuel, the Red Army launched a counter-thrust. Soviet motorized infantry columns, towed artillery batteries, and Katyusha launchers mounted on Studebakers bypassed the German positions, executing encircling movements that threatened to trap von Klest's entire army group. Von Klest admitted in captivity that the offensive failed not because of Soviet defensive tactics, but because the logistics of movement were incompatible. The Wehrmacht could not regroup or advance because their logistical tail was strangled by horse death and truck breakdowns. The retreat of Army Group from the Caucasus in the winter of 1942 and 1943 was a logistical retreat. The German forces were forced to abandon hundreds of panzers and guns because they had no vehicles to tow them or fuel to run them. The Red Army redeployed their divisions along the steppes, driving their Studebakers through the snow drifts to maintain the pressure. The Battle of the Caucasus Petroleum was decided by the side that could keep the transport pipeline running across the mountains, proving that in total war, the logistics of supply will always override the weapons of combat. Chapter 15. The Siberian Express, the Pacific Corridor, was a strategic silent run, operating under a tense neutrality that geopolitical planners in Washington and Moscow had to balance on a razor's edge. While German Luftwaffe bombers were raging over the Arctic and American engineers were building highways in Iran, the ships of the Siberian Express were crossing the Pacific in silence. The geopolitical dynamics of the route were strange. The Soviet Union and the Imperial Japanese Empire had signed a neutrality pact in 1941. Although Japan was an Axis power and the Soviet Union was at war with Germany, both nations maintained this pact to avoid a devastating two-front war. Therefore, Soviet-flagged merchant ships sailed from ports in Seattle, Portland, and San Francisco, carried supplies across the Pacific, and landed at Vladivostok without direct Japanese attacks. But the Japanese High Naval Command was fully aware of the value of the route. They patrolled the Tsugaru Strait and the Sea of Japan, intercepting the Soviet merchant vessels. Japanese boarding officers inspected the shipping manifests, looking for weapons of combat. The Soviet ships sailed under the direct rules of neutrality. The cargo holds were filled with industrial materials such as copper ingots, aluminum slabs, heavy machinery, railway rails, and thousands of Studebaker US6 chassis kits. To deceive the Japanese inspectors, the Soviet logistics officers labeled the military trucks as industrial transport chassis or agricultural utility tractors. The jeeps were listed as civilian forest inspection machines. The Japanese officers, fearing diplomatic complications that would force the Soviet Union to open a second front in the east, accepted the deception. But the transport was a slow and dangerous operation. The ships had to navigate the severe winter conditions of the Sea of Okhotsk. The sea ice packs clogged the channels, and the cargo vessels had to be led by Soviet icebreakers. Many ships were ice-bound for weeks, their civilian crews suffering from cold and frostbite. Once the cargo landed at the port of Vladivostok, it faced a massive transport bottleneck. The Trans-Siberian Railway was the only transport connection linking Vladivostok to the front lines in the west, 5,000 miles away. The Soviet rail network in 1941 was inadequate for the pressure of Lend-Lease imports. The locomotives were obsolete, and the lack of automatic brakes and coupling systems meant that train speeds were limited. Therefore, the United States shipped over 1,900 diesel-electric and steam locomotives to the Soviet Union. The American Locomotive Company, or a LCO, in Schenectady, New York, built the RSD-1 diesel-electric locomotive specifically for this task. These locomotives were shipped complete on the decks of merchant ships. Once arrived at Vladivostok, they were directed to pull the heavy Siberian Express trains. The American locomotives were critical. They featured 6 axles for better weight distribution on the crude Soviet railways and were equipped with automatic braking systems. They pulled convoys of up to 100 cargo cars filled with Studebakers, running without pause across the wastes of Siberia. At remote rail sidings, Soviet mechanics assembled the Studebaker kits directly on the flatbeds. The workers operated in winter conditions, mounting engines, axles, and tires under the gaze of Siberian winds. Once assembled, the trucks were driven off the rail flatbeds using improvised timber ramps. They hooked up with logistical columns in central Russia, driving hundreds of miles to the combat areas. The Siberian Express and the Trans-Siberian Railway collaboration was a strategic triumph. Through neutrality deception, American locomotives, and the majesty of railroad infrastructure, the Allies sustained the Soviet mobilization, proving that in geopolitical war, the arithmetic of transport will always triumph over geographic barriers. Chapter 16. The Kursk Counteroffensive Logistics. The Battle of Kursk in July 1943 is famous in military history as the largest armored engagement on record. The entire narrative focuses on the clash of panzers and T-34 tanks at Prokhorovka and the Soviet defensive preparation of deep anti-tank zones. We are told that the German offensive, Operation Citadel, failed because of the sheer resolve of Soviet soldiers and the strength of the defensive perimeter. But the true strategic miracle of Kursk was not the defensive phase. It was the rapidity of the Soviet counteroffensives, Operation Kutuzov in the Ural sector and Operation Rumyantsev in the Belgorod-Kharkov sector, that followed immediately. In traditional military calculations, an army that has deployed its entire reserves to defend against a massive armored offensive is exhausted. Its supply depots are empty, its units are disorganized, and its artillery is stationary. Consequently, the Wehrmacht command expected the Soviet forces to remain passive for weeks after Citadel was cancelled. But the Red Army launched a counteroffensive within 48 hours. This operational mobility was powered by the Studebaker US6. The Soviet High Command, the Stavka, had concentrated the bulk of the American truck fleets in the reserves of the Steppe Front, commanded by Marshal Ivan Konov. When the German offensive collapsed, Konov's forces were mobilized instantly. Entire infantry divisions were loaded onto Studebakers and transported to the front lines, bypassing the mud-slicked roads. The howitzers of the artillery reserve, heavy 152mm guns weighing several tons, were towed by Studebakers at speeds of 20 miles per hour, reaching the battlefields of Kharkov long before the German forces could establish defensive positions. The logistical flow was a pipeline of speed. The Studebakers carried shells, fuel, and bridge steel from the railheads directly to the advancing tank divisions. In his logs, Field Marshal Erich von Manstein, commander of German Army Group South, recorded the shock of this operational speed. He noted that the Soviet armies moved with a velocity that rendered Wehrmacht defensive cohesion impossible. Wehrmacht infantry division retreating from Belgorod on foot were bypassed by Soviet motorized columns. The Studebakers drove through the rain-slicked fields, carrying Soviet infantry directly to the rear choke points. The Soviet counteroffensive advanced over 120 miles in 2 weeks, recapturing Kharkov and driving a destructive wedge into the German southern front. The logistical lesson of Kursk was extraordinary. The Red Army had won the Battle of Citadel by defense, but they won the campaign by operations. The Studebaker had mobilized the Soviet reserves, converting an exhausted army into an unstoppable motorized force that outrun the Wehrmacht retreat. Chapter 17. The Vistula-Oder offensive. In January 1945, the Red Army launched the Vistula-Oder offensive. This was the decisive campaign that brought Soviet forces from the Vistula River in Poland directly to the Oder River in Germany, placing them a mere 40 miles from Berlin. The speed and scale of the advance were unprecedented in military history. In 23 days, Georgy Zhukov's First Belarusian Front and Ivan Konov's First Ukrainian Front advanced over 300 miles. The strategic depth of the operation was immense. Soviet divisions had to bypass fortified German cities, capture bridges over deep rivers, and destroy multiple Wehrmacht defensive lines. But the fundamental challenge of the offensive was logistical. An armored force advancing at a speed of 15 miles a day consumes hundreds of tons of fuel and ammunition every 24 hours. As the tanks of the vanguard pushed deeper into Poland, they drifted away from their railheads. The railway infrastructure was crippled by German sabotage and demolitions. Therefore, the Soviet Rail Corps had to convert the gauges of the tracks to match Soviet standards, a process that took weeks. To bridge the logistical void, the Red Army relied entirely on its motor transport columns. The Studebakers, towing supply wagons and towing heavy howitzers, operated in continuous convoys stretching hundreds of miles. The convoy routes were operated in extreme winter conditions. Sheet ice coated the roads and snowstorms reduced visibility to zero. The drivers had to run the engines continuously to prevent the coolant systems from freezing. The Studebaker's 6x6 transmission and standard heavy-duty heating systems were the salvation of the drivers. Indeed, while the drivers of the cold German Opel Blitz trucks were freezing in their cabins, the Soviet crews operated in relative comfort, running convoys continuously for 48 hours without pause. The logistical velocity of the offensive was extraordinary. The motor columns carried over 100,000 tons of shells and fuel daily. The Studebakers drove through the fields, bypassing the blocked highways and delivering ammunition directly to the advancing tanks. In his memoirs, General Heinz Guderian, chief of the German Armed Forces General Staff, expressed astonishment over the Soviet logistical mobility. He recorded that Wehrmacht units retreating from the Vistula were constantly bypassed by Soviet motorized infantry columns mounted on American trucks. Guderian noted that the Red Army moved with a velocity that rendered German strategic reorganization impossible. Entire German divisions were encircled and destroyed long before they could reach the Oder River defenses. The Vistula-Oder offensive proved that in total warfare, logistical velocity is the decisive weapon. The Red Army had completed the deep penetration of Poland not solely by tactical steel, but by the speed of American-supplied engines. The Studebaker had propelled the Soviet vanguard to the gates of Berlin, sealing the fate of the Third Reich. Chapter 18: The Logistics of the Battle of Berlin, April 1945. The final act of the war in Europe was prepared. The Red Army was concentrating a massive force on the Oder River, ready to launch the final assault on Berlin. The operations demanded a colossal volume of firepower. The Soviet command deployed over 2 million soldiers, 6,000 tanks, and 48,000 artillery pieces and rocket launchers. The tactical offensive mandated the saturation of German defenses on the Silo Heights, the key perimeter blocking the path to the capital. The Soviet artillery corps had to fire millions of shells in the opening hours of the bombardment. The logistical squeeze was intense. An artillery force of this magnitude fired hundreds of tons of explosives every minute. Delivering this munition from the supply depots to the active firing lines was a massive task. The Soviet Motor Transport Service operated over 35,000 trucks in the Berlin sector. The fleets were dominated by the Studebaker US6. The Studebakers were encountered in every operational sector. They carried shells, fuel, and infantry from the railheads directly to the firing lines. They towed the heavy howitzers through the muddy fields of the Oder Basin, establishing firing batteries in positions that Wehrmacht commanders assumed were inaccessible to heavy weapons. The stability of the logistical pipeline decided the battle. While the defending German forces were stranded by a total lack of fuel and ammunition, the advancing Soviet divisions were fully supplied. The Katyusha batteries, mounted on Studebakers, moved through the streets of Berlin, firing rocket salvos into fortified German buildings and immediately displacing to escape counterattacks. The motorized infantry columns secured the intersections, bypassing the fortified barricades and encircling the German garrison. The mechanical wear and tear on the vehicles during the final weeks of the war was extraordinary. The Studebakers, running continuously on crude roads coated with ruins and steel shrapnel, suffered constant tire blowouts and suspension damages. But the standardization of the American truck fleet was the salvation of Soviet mechanics. They salvaged wheels, axles, and engines from damaged vehicles, keeping the transport columns moving without interruption. On May 2, 1945, the garrison of Berlin surrendered. The victory was celebrated as a triumph of Soviet resolve and military power. But the logistical mathematics show that the defeat of Nazi Germany was an industrial victory. The Red Army had marched from Moscow to Berlin on American wheels, towed by American engines, and supplied by American industry. The Studebaker US6 was the unsung vehicle that had enabled all others, proving that in the theater of total war, the arithmetic of transport will always conquer the myth of tactical perfection. Chapter 19. The Lend-Lease footprint in Soviet reconstruction. The devastating scale of the conflict left the Soviet Union in ruins. By 1945, more than 1,700 cities and 30,000 towns were completely destroyed. Millions of citizens were homeless, and the industrial infrastructure was decimated. The Soviet government faced a colossal reconstruction challenge. Rebuilding cities like Kiev, Minsk, and Stalingrad demanded the mobilization of millions of tons of building materials, timber, and machinery. But the domestic industrial base was still crippled. The railways were under-constructed, and the truck fleets were worn out by years of combat service. This is where the Lend-Lease fleets played a second, unsung role. The Studebakers, jeeps, and heavy machines that had propelled the Red Army to Berlin were redirected to the civilian reconstruction effort. The Studebakers were encountered in every reconstruction sector. They carried timber, cement, and bricks from the railheads to the building sites of Stalingrad and Minsk. They towed clearing machines and heavy machinery, clearing the rubble from the streets of Moscow and Kiev. The structural robustness of the American trucks was the salvation of Soviet reconstruction agencies. Indeed, while the few domestic Soviet trucks quickly broke down under the strain of carrying heavy construction debris, the Studebakers ran without interruption. More critically, the factories established to maintain the Lend-Lease fleet during the war were converted into civilian repair workshops. The standardized parts and tools supplied by the United States allowed Soviet mechanics to keep the transport columns running for years after the end of hostilities. The impact of U.S. steel sheets and machine tools on the post-war industrial recovery was immense. The Soviet automotive and railway industries utilized imported American presses and metallurgy technology to rebuild their own assembly lines. By 1950, the Soviet Union had largely completed the reconstruction of its primary industrial centers. The official state narrative celebrated the victory of socialist labor, but the logistical truth is clear. The ruins of the Soviet Union were cleared, rebuilt, and mobilized on American wheels. The Studebaker US6 was the silent builder of the post-war Soviet Union, proving that the value of a logistical machine extends far beyond the battlefield, serving as the foundation of national recovery and growth. Chapter 20. The Mathematical Triumph. The war on the Eastern Front was a clash of two different military eras, a truth test of strategic concepts. Nazi Germany championed tactical perfection and complex engineering. The United States and the Soviet Union lived by industrial standardization and operational velocity. The tactical superiority of the German panzers and the bravery of their soldiers were undeniable. They executed brilliant maneuvers and achieved massive local victories. But in the theater of total war, these achievements were irrelevant. The Wehrmacht failed because its logistical foundation was obsolete. An army that relies on horses and an unstandardized fleet of delicate civilian vehicles cannot sustain a modern war across a continent. The Red Army, powered by Lend-Lease supplies, developed a logistical machine of extreme mobility. The Studebaker US6 was the mechanical platform that enabled this transformation, converting a slow, horse-drawn army into a motorized vanguard that outrun the Wehrmacht. The mathematical triumph of the Allied victory was a triumph of Detroit over Essen, of South Bend over Stuttgart. It proved that the bulldozer and the truck are indeed the true decisive weapons of war. In the final analysis, the Eastern Front demonstrated that in total warfare, logistics is the ultimate variable. Tactics will win battles, but logistics will win the war. If you want to dissect the historical documents, shipping manifests, and Wehrmacht logs that document this logistical asymmetry, we invite you to download the Eastern Front Logistical Archive at the link in the description. It provides a complete database to help you analyze the math behind the Allied victory. Subscribe to our channel as we continue to challenge the myths of military history and uncover the hidden strategic formulas of war. The end. Chapter 21, the Dodge WC and Willys Jeep while the Studebaker US6 was the backbone of the heavy logistical transport lines. The motorization of the Red Army was supported at the tactical level by a fleet of lighter, highly mobile American vehicles. These were the Dodge 3/4-ton weapons carrier, known to the Soviets as the Dodge 3/4, and the iconic Willys MB Jeep, known affectionately as the Willis. The tactical requirements of frontline infantry battalions, reconnaissance squads, and communication units were completely different from the needs of the supply depots. They did not require cargo trucks to carry 5 tons of ammunition over long distances. Instead, they required small, agile, 4-wheel drive vehicles to navigate the active shell craters of the front lines, carrying light machine guns, wounded soldiers, and radio equipment. The Soviet domestic industry had no equivalent for these vehicles. The lack of all-wheel drive technology meant that Soviet light transport was restricted to draft horses or civilian passenger cars that sank instantly in the mud. Therefore, the shipment of over 50,000 Willys Jeeps and 25,000 Dodge WC series vehicles transregulated Soviet tactical mobility at the squad and company level. The Dodge 3/4 was a mechanical revelation. It was equipped with a 6-cylinder Dodge T214 engine producing 92 horsepower, coupling with a 4-speed manual transmission and a single-speed transfer case. The vehicle featured a very wide track and low profile, providing exceptional stability on steep mountain passes and cratered fields. The large, deep-tread tires and the 4x4 drivetrain allowed it to pull light anti-tank guns directly into firing positions. Soviet reconnaissance units standardized their operations around the Dodge. They mounted heavy machine guns on the cargo beds, converting the weapons carrier into a highly mobile combat platform that could execute rapid raids into the German rear. The Willys Jeep played an equally critical role. It was the universal transport workhorse of the frontline officers and communication scouts. The Jeep's compact size allowed it to be concealed in shallow trenches or under forest brush, saving it from German air reconnaissance. The Red Army utilized the Willys Jeep for communication line laying. Scouts mounted giant reels of telephone wire on the rear of the vehicle, driving through active combat fields to connect division command posts under shell fire. In his memoirs, Soviet Army general wrote that the Willys Jeep was the salvation of the communications network. Indeed, during the rapid offensives of 1944, when the infantry advanced beyond the range of stationary radio units, the Jeep-mounted telephone lines were the only connection keeping the division commanders in touch with their regiments. The tactical supremacy of the American light vehicles was a victory of engineering design. The Dodge and the Jeep were built for the realities of the combat field, proving that mobility at the squad level is the piece of infrastructure that enables all combat tactics. Chapter 22. The Soviet drivers experienced the strategic convoys and tactical offensives were operated by the unsung heroes of the Red Army, the drivers of the motor transport service. These men, workers recruited from civilian sectors or unskilled conscripts, operated the vehicles under environmental and combat conditions of extreme friction. The physical realities of driving on the Eastern Front were grim. The roads were paths of deep clay, cratered by artillery and coated with the debris of burning convoys. In the winter, the temperatures collapsed to 40 degrees below zero, turning the oil in the engines into solid clay. The Soviet drivers had to develop brutal field hacks to keep the vehicles running. Because the Red Army lacked glycol antifreeze, drivers had to drain the radiators of their trucks every night to prevent the water from freezing and cracking the engine blocks. In the morning, before the engine could be started, the driver had to build a small wood fire directly under the oil pan of the truck, melting the frozen grease. They then poured boiling water into the radiator, hoping the engine would ignite before the water froze again. The difference between driving a Soviet GAZA and an American Studebaker was the difference between torture and luxury. The Soviet driver Ivan Kozymiako recorded this comparison in his war diary. Kozymiako wrote, "The GAZA was a beast of pain. The cabin was made of wood and canvas without a heater. The wind swirled through the cracks, and in winter, our hands froze to the steering wheel. The mechanical brakes were useless, and if we had to go down a sloping road with a heavy load, we had to shift into low gear and pray the driveshaft would not break. But the Studebaker was a revelation. The cabin was all steel, warm and sealed. The heater worked constantly, and the vacuum brakes worked with extreme precision. It proved to be a vehicle that cared for the soldier." The drivers of T.H.E. Studebakers faced constant danger from German fighter planes. The Luftwaffe's Ju-87 Stuka dive bombers and Focke-Wulf 190 offensive ships targeted the supply lines, machine-gunning convoys along the open steppes. To escape these attacks, the Soviet convoys operated primarily at night, driving without headlights to avoid detection. The drivers had to rely on the glow of the exhaust manifolds of the vehicle ahead or the direction of white stakes driven into the mud by road guides. The mechanical expertness of the Soviet drivers was born of survival. They learned to repair broken drive shafts, fix punctured tires with canvas patches, and run engines on low-grade kerosene. The Studebaker's design simplicity was the majesty of its success. The mechanics in field workshops could salvage components from damaged trucks, keeping the transport pipeline moving. The Soviet driver's story is a story of endurance and industrial support. The Red Army advanced to Berlin on American wheels, driven by Soviet manpower, proving that in the calculus of war, the logistics of vehicle repair will always overcome the friction of geography and combat. Chapter 23. The Arctic Convoy Sailors' Ordeal. The convoys sailing to the northern Soviet ports were battles of physical survival, not just against the German Navy, but against the geography of the Arctic Circle. The cold Barents Sea was an operational hell in the winter, with snowstorms reducing visibility to zero and sheet ice coating the ships. The ice formation on the decks of the merchant vessels was a constant threat. Indeed, as the spray of the severe seas splashed over the bow, it froze instantly, coating the cargo crates, gun perimeters, and decks with tons of solid ice. This ice accumulation created a dangerous stability risk. The ships become top-heavy, threatening to capsize in the severe Atlantic waves. Consequently, the civilian sailors had to stand on deck during snowstorms, using axes and shovels to chip away the ice by hand. The danger of frostbite was critical. The winds reaching speeds of 50 miles per hour dropped the temperature to 40 degrees below zero. Sailors who touched uninsulated metal tools with bare hands suffered instant skin damage, and many lost fingers and toes to the cold. The Battle of Convoy PQ-18 in September 1942 demonstrated the operational danger of the route. The convoy encountered devastating attacks by Luftwaffe bombers and U-boats. The Luftwaffe 5th Air Fleet deployed massive attacks, with torpedo planes flying in formations of 40 vehicles at wave-top height. The merchant ships and escort groups responded with an intense defensive barrage, converting the ocean perimeter into a wall of fire. The sailors on the cargo ships had to maintain their stations under air shelling, firing anti-aircraft guns and manning the engines as bombs exploded in the surrounding waters. The destruction of the cargo ship Mary Luckenbach was a symbol of this fear. Hit by an aerial torpedo, the ship, which was packed with explosives and Lend-Lease vehicles, exploded in a giant fireball, disappearing in seconds with all crew. But the convoy held its defensive cohesion. In total, the escort groups destroyed 48 German planes and 4 U-boats. Though 13 merchant ships were sunk, 27 arrived at Murmansk and Arkhangelsk, unloading the critical supplies that saved the Soviet Union from the void. The port infrastructure of the northern ports was constantly bombarded. The Soviet dock workers, most of them women and adolescents, unloaded the heavy crates of Studebakers under the glow of searchlights, as the German air raid alerts wailed continuously. The dockworkers moved cargo in the darkness to escape bombing, sliding the crates onto timber sleds to move them across the frozen soil. The assembling of the trucks in improvised outdoor workshops was a triumph of human endurance. The mechanics worked without heating, using fires to keep the grease and oil in a liquid state. Once assembled, the Studebakers were driven directly to the front lines, pulling howitzers through the snow to support the defenses of Leningrad and Moscow. The maritime gauntlet proved that the logistical lifeline could not be severed. The civilian sailors and dock workers had defeated the Luftwaffe and the cold, proving that in geopolitical warfare, the arithmetic of cargo shipments will always defeat the forces of strangulation. Chapter 24. The Siberian Express Operations. The Siberian Express was a pipeline of scale, traversing the vastness of the Asian continent to deliver the industrial materials of America to the battlefields of Europe. The geographical distances of the route were staggering, stretching over 5,000 miles from the port of Vladivostok to the Urals. The Soviet Trans-Siberian Railway was the sole pipeline connecting the east to the west. In 1941, the rail infrastructure was paralyzed by obsolete equipment and the massive evacuation of factories to the east. The engines were underpowered, and the lack of automatic couplings meant that cargo trains had to be limited in size. Indeed, the train speeds on the Siberian line averaged less than 10 miles per hour. Therefore, the shipment of American locomotives and cargo cars was the salvation of the rail system. The Alco RSD-1 diesel-electric locomotive, shipped by the Allies under Lend-Lease, reorganized Siberian logistics. These locomotives featured 6 axles, distributing the heavy weight over the weak Soviet tracks, and were equipped with automatic air brakes that allowed them to pull convoys of up to 100 cars loaded with Studebakers. The Siberian railway workers operated in a system of extraordinary tension. The trains sailed continuously, running the locomotives without interruptions by shifting crews on the move. The drivers had to navigate the severe Siberian winters, where snowdrifts blocked the passes and the temperatures collapsed to 50 degrees below zero. The coal reserves were frequently frozen, demanding that the firemen use pickaxes to break the coal blocks before feeding the boilers. At remote rail sidings in Siberia, assembly plots were established. The mechanics worked in the open-air fields, unpacking the completely knocked-down containers and assembling the Studebakers directly on the rail flatbeds. The mechanics had to work under Siberian winds, using fires to melt the grease and oil. Once the chassis, engine, and cabin were assembled, the trucks were loaded with cargo and driven off the flatbeds using timber ramps, hook up with convoy routes to the front. The Siberian Express defeated the tyranny of the logistical void. Through covert diplomacy, industrial locomotives, and the majesty of railroad engineering, the Allies sustained the Soviet war effort, proving that in total war, the arithmetic of logistics will always conquer the barriers of geography. To be completed in the final turn. Chapter 25. The geopolitical irony of Lend-Lease. The cooperative effort that had defeated Nazi Germany did not survive the arrival of peace. The moment the German instrument of surrender was signed in May 1945, the strategic pipeline of Lend-Lease was halted. Under the terms of the Lend-Lease Act, all military hardware that had not been destroyed in combat was property of the United States government. Consequently, the U.S. State Department issued demands to the Soviet Union for the return of the vehicles and machinery. The geopolitical irony was staggering. The United States had motorized the Red Army to defeat the Wehrmacht. But now, with the rise of the Iron Curtain, the U.S. faced the reality of a fully motorized Soviet military threatening occupied Western Europe. The Soviet government had no intention of returning the trucks that formed the backbone of its transport network. They claimed that the vast majority of the Studebakers had been destroyed in combat or worn out by wartime operations. When the United States insisted on physical inspections and the return of surviving vehicles, the Soviets executed a passive resistance. They gathered thousands of worn-out Studebakers, crushed them using heavy machinery, and shipped the scrap metal back to the U.S. in crates. To reconstruct the motor fleet of the Cold War, Soviet engineers launched a campaign of reverse engineering. They took the surviving Studebaker US6 vehicles, disassembled them piece by piece, and copied the blueprints. The result was the Soviet ZIS-151 and the later ZIL-157 trucks. These vehicles were mechanical copies of the American Studebaker. They featured the identical 6x6 suspension, the same chassis dimensions, and copied the cab controls. The Soviet logistical tradition of the Cold War was an American legacy. The trucks that pulled the Soviet artillery during the Hungarian Revolution and the Warsaw Pact off-road exercises were direct descendants of the machine built in South Bend, Indiana. The strategic story of Lend-Lease proved that in geopolitical conflict, the material of alliance cannot be recovered. The United States had built the transport machine that defeated Germany. But they had also built the machine that would challenge them for the next 40 years, proving that the logistics of war will always define the politics of peace. Chapter 26. Conclusion. The arithmetic of victory. The story of the Studebaker on the Eastern Front is a strategic correction to the popular history of World War II. The conflict was not won by the side that produced the most fanatical soldiers or the most complex armor. It was won by the side that standardized its drivetrains, resolved the geography of mud, and built an endless supply line. The American arithmetic of Detroit and South Bend conquered the Wehrmacht's horses and unstandardized fleet. The Studebaker US6 was the true decisive vehicle of the Eastern Front. It towed the heavy howitzers, stabilized the Katyushas, mobilized the infantry, and cleared the ruins of the cities. In the final analysis, the Eastern Front demonstrated that in total warfare, logistics is the divisive variable. Tactics will win battles, but logistics will win the war. If you want to dissect the historical documents, shipping manifests, and Wehrmacht logs that document this logistical asymmetry, we invite you to download the Eastern Front Logistical Archive at the link in the description. It provides a complete database to help you analyze the math behind the Allied victory. Subscribe to our channel as we continue to challenge the myths of military history and uncover the hidden strategic formulas of war. The end of the document. Chapter 27. The logistics of the Trans-Caucasus Highway. The mountain passes of the Caucasus were the final and most critical stretch of the Persian Corridor. While the desert assembly plants of Andimsk turned components into machines, it was the Trans-Caucasus Highway that proved to be the physical link between Allied supply and Red Army combat. The highway route running from Tabriz in Iran to Julfa on the Soviet border and north to Baku was a geographical maze of sheer cliffs, narrow roads, and extreme elevation changes. The climb across the mountain passes reached altitudes of over 8,000 feet. In these thin atmosphere conditions, the Hercules JXD gasoline engines of the Studebakers suffered from power loss. The air density reduced the cylinder charge, causing the engines to overheat constantly under the strain of towing heavy howitzers. To prevent engine seizure, drivers had to run the heating systems in the cabin at maximum capacity, redirecting engine heat away from the block. Indeed, in the midst of summer, with outdoor temperatures reaching 100 degrees, the cabin temperature was a suffocating hell for the crews. The descents were equally dangerous. The vacuum-assisted hydraulic brakes of the Studebaker were the only barrier preventing the trucks from plunging into the deep ravines below. If a driver maintained the brakes for too long, the brake drums overheated, causing brake fade and complete loss of deviation control. Consequently, the drivers had to master the art of engine braking, using the low-range gears of the transfer case to control the vehicle's descent. The tactical coordination between Soviet and American transport groups was in complex drill. The vehicles moved in convoys of up to 100 trucks, spaced exactly 50 yards apart to prevent collision in case of brake failure. The road service of the Red Army established repair and maintenance hubs along the passes. At these shuts, mechanics worked in the open-air bays, replacing worn brake pads, repairing blown head gaskets, and changing tires. The logistical flow carried over 2 million tons of military hardware and petroleum products. The Studebakers not only pulled the artillery, they carried the steel drilling cables, drilling mud, and refining equipment required to keep the Baku oil fields operating. Baku was the strategic heart of the Soviet Union. Indeed, the Baku wells produced over 80% of the country's aviation fuel and lubricants. If the Germans had seized the Caucasus or cut off the Trans-Caucasus highway, the Soviet air and armored forces would have been grounded. The lifeline carved through the Zagros and Caucasus Mountains was the geopolitical bulwark that secured the Soviet oil supply. The unsung trucks of Indiana had driven across Iran and the Caucasus to deliver the logistical scales of victory. The Trans-Caucasus Saga proved that in total warfare, the geographical barriers of mountains and deserts can be conquered by standardization and the endless flow of motor transport, redefining the geometry of operational logistics.